Well, today's video is sponsored by Rosemary. Rosemary on our chat here and the comments, etc. She sent a nice donation that made it possible to buy the epoxy. And I think I'll do a few videos like this showing, some of you guys great donations and showing where your money went. In this video, thank you, Rosemary. You're outstanding. I'm sure everyone else thanks you also. In this video, I'm going to show you, I can make these three pieces rather, act as one. It's going to be an amazing little find for you guys. I'll explain in about 3 series of videos to do this. So this will be the short version of it. Shout out to Rosemary, and we'll see this loaded. Remember, the loading on this only needs to take. The surface that I'm going to load is going to be far less than 1 square foot, and we're going to load this with an epoxy, and we're going to see how it bonds. Now, the epoxy sets up, so you know, you use about 75% of the rating of it, so about 7,000 psi. So it's got a lot more rating than you may think. So now let's go ahead and show you what it looks like with the epoxy. It's going to be a thread all that I'm going to stick in here for the future part of the videos. It's going to be about 3 videos of these to show you the cycle of this one before it fails and then comes back to life again. So I'm going to take it to failure and then bring it back to life again using epoxy and the screws. We shall see. We're going to do a twofer, right? 2 for 1. 2 for 1. We're going to test the plate. And these screws, right? This plate and these screws. I'm going to put it on top of the critical shear area. Top. I'm going to load it out here. We'll make sure you can see it. Let's get to it. Okay, so mostly my loading is straight down, and then the columns and everything shift. And we get the separation, and you see it goes off roughly at that 35, 45 degree angle. Now, it's going to be very interesting in the future videos about that angle. Keep note of that. And I'll talk to you about it right now for just a moment. Look at the video, and right above that triangle of concrete that's left, that would be the tension side of this failure, and below it is the compressive side. And you see it pushes the forces are, well, it was centered over the screws, and the screws are where the forces resolve themselves at and created that fracture. So my reinforcement is also where the fracture came from, and you see the center axis of it, neutral axis of it, right where you see it, where it fractures from there down. So it's not always in the center, but now you see where it is. Oh yeah, thank you for asking. Yeah, I'll answer your question. Why did it break there? Well, that's where the screws are anchoring the 2 sides together. So ultimately, that's the connecting piece section that the screws are. Of course, the back side of the screws don't secure as much as the front side of the screws, and vice versa, depending on how it's loaded. And that's where I'll show you a close-up where it fractures right in the center line of the screws, the anchoring. And so even the screws have a neutral axis to them. And it fractures on right center line, and you'll be able to see it in just a moment when I present it. But I want you to take a few cycles of this, and I'll get right to us. We'll look at the screws now. That was interesting to watch, wasn't it? It burst. So now you'll see the screws, and you'll see the anchors I used, and you see right in the middle of the screw is where it fractured on each side of it. So there's the neutral axis of the anchoring presenting itself. I'm going to zoom in again on it a couple times so you guys can pause it even. But there we are. And we have 3 pieces now. And now let's put them together like Humpty Dumpty. but they'll work. So you can see how it works. Now you can see how those threads work inside there. And they do thread. Oh, let's put that one aside and grab one that you can see, observe. See the threads? There's the concrete that's still inside the threads. So our grip force took place. Well, our torque, our axis point was where I believe the motor is still in it. We'll connect it and bond it with the threads. Not down here, but up there. Let's put this back into place and take a look again. Back side of it. There's our materials that have been crushed and turned to powder, if you will. Oh, and we got a fractured brick. Okay. So let's look at this still. And now let's look at the underside of it. Threads. Threads. They still feel like threads. Which means if they feel like threads, it didn't strip it out, but it burst it apart. And there's our axis point, our rotation, our fracture, our 45. Right to my anchor. So that's very important for you engineers out there. It went right to the top of the anchor, that 45 did. And then it went along down, splitting each side. Looks like almost like a perfect 50-50 on each side of the anchor at that point. And remember, the anchor, the paste was on the anchor was at that height. So I wonder if I use a longer screw, I can make a different. And I'm not going to do it in this video. That'll be part of somebody else's sponsored money, and I'll do a video that will do this, and I'll use a longer screw, and I'll see if we can change the axis point based on the screw height, the anchorage, and see if we can get this 45 to move up. We'll see if that happens. It takes time to make these videos, people, but I really appreciate your financial support that you guys have sent me, so I'm going to do this content for you. Okay, so now look at the screws, the bolts, and screws, and I determined that there's no elongation that took place. I did use a micrometer on it also, but no elongation took place. Okay, let's have a little fun. Let's use some thread all. All right. Let's get a little closer, and I got about 5 minutes to work with this product, and then it's done. So let's go ahead and epoxy, see how you're doing. As long as I keep recharging it. Let's do that. Let's put epoxy on each one of these surfaces. And over here. Sorry guys. And then we're going to clamp it together. Once this hardens, it won't allow for expansion. Okay, so we got a nice bead of epoxy on that. Now let's put this back together, this fractured piece. Well, that looks like that's about the end of the product. So let's go ahead and get this back together, clamped up. Well, that was brilliant. I wanted to turn it upside down. So you can see it better. Okay. So now we just wait. Now you just wait a few minutes. Magic of time lapse. We'll see what happens. While we wait, let's look at the columns. There's a set of 6. There's a set of 4. Now, I want you to imagine a set of 4 as it transitions from 6 pieces of rebar to 4. Remember, they transition from 4 to 6 at the 8th floor, I believe. So it would be from 6 to 4. So at the 6, I want you to you can see that if I push on this uniformly, if I load this uniformly, that as I push on it, let's see. As I push on it, I've got it. This will go into tension. This will help in that reaction too, and so will this one. If I pull one out, I'm now down, reduced to 4. I lost this. This is my resistance from the column rattling. I lost it now. Now I've got a lot more shaky column as opposed to, here's 2, as opposed to 6. A lot more stability, integral with the concrete. I only need to cause this to fail by spalling off a little bit of concrete off the face of this. Remember, the concrete's probably only as wide as this brick. It only needs to spall off that much, and now we're lost its ability of that in 2 directions. It would spall off the side too, perhaps. With the 3, though, we've got a lot more redundancy. So as we turn to the 4, so we have some redundancy and more strength, obviously, but I want you to see the redundancy. As we turn to the 4 pieces, I need you something you can see move. So as we turn to 4, and I'm going to move the 4 of them together up top with my hand. I'm just going to do this. As you can see, it doesn't take much. Wait a minute, let me zoom out. So it doesn't take much to get these column rattling. Of course, concrete's in there, But if it rattles, the concrete spalls off. You then get a reduction. Remember, the steel they have in here is only a few more pieces going across. So they've got this cross steel going in here, like that. Let's turn it so you can see the color. It's not very much, is it? And remember, that's the face wall out there, so this would be the C column. The face wall is out here. There's nothing there, airball, sky. And then they supposedly have a piece of rebar in two directions. I'll lay it on the ground for this one. Oops, got the clear epoxy. Okay, so I want you to notice now the piece put back together, but with epoxy. It sat overnight, and I put a thread alls inside there, but as you can notice or take note, there are no bolts, and I have it upside down. So the only thing holding this together now is the epoxy, because that would be, that puts that plate in compression. But, so the epoxy was just smeared in there basically, and then clamped closed, and now we're going to load it. Now the deck only requires 40 pounds per square foot. I'm going to bring that to 45 pounds and about 1 square inch. Let's see. So here's the plate. And interesting, this will be my first video, the first loading of it. Good. I didn't want to. So, ooh, you didn't see it. Okay. So there's 45, and that's just epoxy. Epoxy on it. I didn't even bolt down the plate or turn it upside down to load the tractor on it. This is showing you that the epoxy, so you guys are wondering if epoxy is any good. It shows you that epoxy does a great job of bonding two surfaces. Well, that looks like that's about the end of the product. So let's go ahead and get this back together, clamped up. But it's also the tension in those surfaces, how much epoxy you can get in the full bed of it, the full surface area. And so that would be here, and down here. And that's the tension area. Let's see if it's opening up. It's in tension now there. Oh, you see how I got it on two supported bricks. Not much. In fact, that one's just shimmed so I can keep it kind of level for us. But as I zoom in, that's just dirt. You see again that the epoxy is holding well. The epoxy is holding well. Let's see if I can move that piece of whatever this is. Oh, a nice piece of wood that I used to stick hold it up. This piece of wood that I broke off that I stuck in there to jam the epoxy. So there you can see that I didn't do a great job right there. Well, there's some epoxy bleeding through a little bit. But not, it could probably do a little better. Let's see if I can move the camera over. Yeah, you can see the epoxy inside there. Inside the voids. Right about there. Let me see the camera. Inside there. You can see the epoxy. So, again, you see no movement. It's firm. Now it's also 7,000 psi, and the surrounding surface is not 7,000 psi. It's the tensile strength of the epoxy also, and how well it bonds. Again, this is 45 pounds, and I would say it's less than 1 inch. That surface of the 45 pounds is down to that weight, the radius of that weight. So it's focused on there, a lot less than 45 pounds. I was leaning on that one a little bit. So leaning on that would drive it down that pin a little bit also, the weight. So let's see if I can adjust that where it doesn't lean on it. I mean where it leans on it, but... Let's back it out. Now let's load it again. This is I think this is my 12-pound sledge. Okay. £25 weight. Okay. So now we've got 50, 70, 80 pounds. All less than a square foot. So we're double, and we have no failure going on. Now for fairness, I'll leave this on here overnight, and I'll post this video now, and if there's any update I have to give you, I will give you an update. But we're going to leave it double the load. Double the load. 45 and 25. So there's your, I know you hear this grinder in the background. 70 plus the 10-pound sledge. I'm trying to think if I got another weight around here real quickly. And these bricks are about 5-pound bricks, 4-pound bricks. We'll throw that up there too. Here's a sledge right below me. This is another 12-pounder, or this might be the 16-pounder, or whatever it might be. There we go. So now that's on the plate, so that pushes the load on the one side. But nevertheless, we'll stack it stacked up. And as you can see, we've got no failure, but yet you saw the machine load it and fail. You know what, the weather's still nice. Maybe I should take the machine and load it for you. I don't have my bolt ready though. I've got to get a bolt and everything else. Let's see what happens. Well, you see the heavy loading, over 100 pounds, and part 2 to come. And later, when you get really good, you can make concrete come to you like a magnet. Look at that. Comes off the ground into my hands.